Hi, I'm Brian Case, and I'm going to be doing my project 2 on topic 19, which is making and breaking of concrete test cylinders, what they tell us, and understanding the compressive strength. What do concrete cylinders tell us? Concrete cylinders tell us the compressive strength of the Portland cement being used at the site. Cement mixes can range in compressive strength controlled by water to cement ratio and various uses of admixtures. Depending on the desired application, the compressive strength can vary from 2,000 psi to 17,000 psi. Different strengths are required for various parts of the foundation. 8,000 psi is considered high performance, and a psi of 17,000 is ultra high performance, which is commonly used as foundation for much taller buildings and skyscrapers. The process of making concrete test cylinders. Most concrete in North America is mixed at batch plants. Companies in Idaho, such as Sunrock and Knife River, have many batch plants throughout the state. Batch plants have lab equipment engineered to produce the quality needed, varying on the project specifications. Each load of transit mixed concrete is driven to the site with a certification from the batch plant that lists proportions and ingredients used in the mix. Upon arriving, engineers take samples from each truck and site cast cylinders. Once the cylinder forms are full, they are taken to a testing lab within 48 hours of pouring. At the lab, they are allowed to cure for a specified amount of time. If the samples are not up to the required standard test, cores will then be drilled from actual members of the batch in question. Test cylinders can also be cast and cured on site so that it is under the same conditions as the concrete in the forms. How to determine strength of concrete test cylinder samples. Strength of cured concrete is primarily dependent on the mix ratio of water to concrete. Because concrete cures through a process called hydration, which is the chemical bonding of water and cement, it is important to keep it moist until it reaches the strength desired. This can be achieved through allowing it an average of 28 days to cure, although the longer it cures, the stronger the concrete can get. Concrete strength is measured in two units: pound force per square inch, PSI, or megapascal, MPa. These are the two most common units associated with compressive strength of concrete. In the lab, engineers record diameter and length of the cylinders, as well as how long it has been allowed to cure. Test cylinders, after curing for a period of time, are placed into structural testing machines. These machines are essentially hydraulic presses that use a piston to lift the lower bearing, compressing the cylinder using hydraulic fluid. The concrete cylinder will continue being compressed until it breaks. Once broken, the engineers will read the machine data to determine the compressive strength of each batch. During the testing phase, if the concrete test cylinder samples end up resulting in failure, engineers will begin to assess the possible causes. Failure of samples could be anywhere from the initial casting of the cylinders on site to improper curing conditions or improper handling of the samples during testing. While this is going on, concrete cylinders will also be drilled from the forms on the site and tested again. If these fail as well, the contractor may be required to remove all concrete from the site and start again. Not only will this cost the contractor to remove it, but it will also impact the critical path of the project by waiting for the concrete batch plants to mix again, transport, and run tests one more time before building. The American Concrete Institute is a leading authority in research worldwide for development, distribution, adoption of consensus based standards, technical resources, education, and proven expertise for individuals, organizations involved in concrete design, construction, and materials. The American Concrete Institute has requirements for structural concrete and strength. These codes can be found in ACI 318-19. These state that the average strength of three consecutive test cylinders should be greater or equal to the design strength needed for the foundations. For strengths of 35 megapascal or less, the compressive strength should not be less than 3.5 megapascals. If the strength is greater than 35 megapascals, it should not be less than the strength designed by more than 10%, otherwise resulting in a failure. Breaking concrete test cylinders helps to determine the compressive strength of the concrete being used. It also helps us decide whether the structure that we are trying to build is ready to be built upon top of the concrete. This concludes my project number 2. I found it very informative when I was studying. Hopefully it shows through in this presentation. Thank you for watching my video.